So a few days ago I made a video where I showcased my ground indicators that no one cared about, and I thought to myself, how about making a step-by-step tutorial series that nobody will care about also? Anyways, what you are seeing right now are indicators done without any textures, just pure math. Of course you can add textures on top of it if you want to, anything is possible after this tutorial. Assuming that you know nothing about materials, I try to explain everything without taking too much of your time. And if that isn't enough for you though, and you want to really understand the materials for the ground up, there is this beautiful man and his 5-minute material series. There are only 3 main types of indicators: box indicator, circle indicator, and the one where people either stop making them and go buy indicators, or will never create it, the cone indicator. Anyone saying, but there is this 4th indicator, the one with multiple boxes in a cone. Yeah, and will you box trace it? Or will you just spawn it with projectiles with their own traces? Or maybe even more projectiles. Or more projectiles. Yes, technically it is another indicator, but it also works differently than the others, so if this tutorial series will get good reviews, which I doubt, I make another video with that one also. Also, you can find the project files with full indicators already done at my Patreon. And now, let's get started. Create the material first by right-clicking in the content browser and name it box indicator. It will be a translucent material. First we get a texture coordinate which gives us UV coordinates, and with a component mask we can select the specific coordinate. In this case, mask R, which is U-axis, and mask G, which is V-axis. For both of these, I'll create a named reroute node with corresponding names, so I don't have node lines all over this material. Now just get U-axis and get step node. Use this as Y, and the X will be scalar parameter. To create one, hold S and left click. This will be fill amount, where 0 is empty and 1 is full. Now when we preview, you can see what it's doing. If we would use V-axis, the fill will work in a different direction, because we are getting different coordinate. If you want opposite side, then you can 1 minus it, which just inverts anything. I will also create a named node called fill for this. Now the fill works, but we still don't have the outline, which shouldn't be filled by this. First, let's compute outer box, which is the full texture. Grab a U-axis and step. Then grab another U-axis, but 1 minus this one. Copy it all and just replace U-axis with V-axis, and now hold M and left click to create a multiply node, and plug them all into it. This multiply node is often used just to layer stuff on top of each other. For this, I will also make another named node called outer box. For the inner box, first create a scalar parameter for outline thickness by holding S and left clicking. Here I will divide it because I want the numbers to be around 0.5 to 1 because all the parameters will be around those values. To create a divide node, just hold D and left click. Copy the outer box and to each Y step add the thickness after dividing. This will be named node called inner box. If you delete the divide, you can see how the number will have to be incredibly small for it to actually work properly. To calculate outline, first get computed boxes and subtract the inner one from the outer one. This will give you your outline. Always be careful with this one and what you put where, because when subtracting, it really does matter. Get the texture sample 2D and layer it with outline via multiply. This will give you opportunity to add your own texture to the outline. Lastly, get constant 4 and convert it to parameter by right-clicking on it. This will be outline color and layer it with last multiplication. This will give us outline, so I will make a named node for that. We are still missing the fade that will make this look even more beautiful. I want the same side as the fill, so get the U-axis, and now you can either clamp or saturate. Both do the same thing and clamp the number between 0 and 1. 0 means black and 1 means white. Essentially that's the all math we are doing, just playing around with zeros and ones to get the masks from black and white, which will be translucent where we need it. Then use power node that raises the exponent's power by a value. This value will be another scalar parameter named fade intensity. Now multiply it by inner box so we exclude the outline from fading, and also multiply it by fill that is inverted, so it won't be on the fill also. We are inverting it because to get the fill we need it to be white, because black means it ignores it or it's translucent. But here we already have the fill mask, but we don't want it there but where it's not filled, and that's why we are inverting the mask. The fade mask is now complete and it will go to a lerp. Hold L and left click to create one and plug it into the alpha. Lerp essentially just blends between two input values based on a third input called alpha. The A will be a constant with value 0, which means black color or translucency, and the B will be multiplied by fade color and also fade texture, both which will be parameters. Now this creates fade color, which I will name my named node 2. The last thing we need to do is connect these functions together to make the material. First, grab the fill and multiply it with inner box. This will remove the filling from outline, so only the inner box will be filled. Create another texture sample for fill texture and another constant 4, converted to a parameter, for fill color. Multiply them with the return value of the last multiply. Add fade color to it and also add outline. Now, if we plug this into output of the base color, emissive color and opacity, it looks great, but there is one slight bug. The outline has translucency, which will affect the coloring and how it looks. So unplug the opacity and get another add. There we will exclude just the outline, which is calculated by subtracting inner box with the outer box. And now plug this into opacity. This works, and you can see there are a lot of parameters that you can edit yourself to your liking. Also, if this wouldn't be enough and you would like to have some animations through textures, you can just add panner, get time, and set in which direction you want the texture to move to. If you can't see it moving, go to this button and enable real-time preview. That's all beautiful, but this was the easier of the two materials we are making today. The second one will be for the circle and cone indicators. So create another material, again set it to be translucent, and first let's start by making our middle point in texture. Get texture coordination and subtract vector 2 from it. Both will be 0.5. This will be named reroute node called center. With that, we can create calculation for full circle. First, get the center and length it. This will make it a radial gradient and technically just gives you the distance from the center. Get if and set this as b and constant 0.5 as an a. For a is bigger than b, copy the constant and set the value to 1. And for the others, copy again and set the value to 0. This I will name calculated full circle. From this, we can calculate the outline. First, create a scalar parameter for outline thickness. I will 1 minus it, so 0 will be no outline and 1 will make everything an outline. Now I will divide this by 2 and subtract this from 0.5. This I will name outline thickness. Basically, almost every number will be only from 0 to 0.5 in this calculation part. But for me and your easier editing, I want it to be from 0 to 1. That's why I'm dividing it by 2 and then I'm subtracting it from 0.5, which is essentially just getting the whole circle and removing thickness of an outline from it, so we can later calculate inner and outer radius properly, because we don't want the radii to go through the outline as well. Create another if, and outline will be b, while a will be center with length. Now get the two constants, and if a is greater than b, output value 1. If not, output 0. Now you can see that this is exactly how the outer radius will behave. It will be full, but it will have the outline space cut off, just like in the box material. To get the actual outline though, we must multiply this with calculated full circle, which will give us the named reroute called outline. To calculate both inner and outer radii, create a scalar parameter for both and divide them by 2 for reasons already explained. But subtract outline thickness only from the outer radius. Now just copy the if from outline for both, and for outer radius it will be a, and for inner it will be b. The remaining part will be center with length, or in other words, distance from the center. Now create for each one named reroute node. To get the cone from these circles, we need to create a mask that will select cone properly based on degrees. Start by getting the center and get both u and v axes with component mask. Now use arctangent 2 and divide it by this number. Then add 0.5 to it and subtract this as b with scalar parameter that we will create named rotation. To normalize the number, I will use fraction and I will output it as angular distance. Create another scalar parameter for outline rotation and copy this here. This will be outline angular distance node. Changing the rotation will show you what it does. We calculated the center of our cone. To compute the mask, create a new scalar parameter called degrees and plug it into if as a. The b will be 360, and if a equals b, it will output constant with value 360. If not, get outline thickness multiplied by 100 and subtract it from the degrees. This will create cone side outline if it is a cone, and not if it is a circle. Now divide this by 360 because we will create a custom node wanting only normalized numbers. Get custom node and add this code to it, which will be in the description. Flag angular distance as an A and degrees as an L. This will be cone circle angle named node. To immediately show you how it will create the outline, copy all of this here and remove these parts. Now you can see one is smaller than the other while also keeping every value in check, so if it is 90 degrees, it really is that much with the outline, not more, not less. Subtract this with cone circle angle and subtract from it for a circle inverted with -1. This will be cone side outline node. Go back to calculating outline and let's calculate cone outline as well. Multiply this with cone circle angle and create cone outline node. For the fade, we create a constant 4, make it a parameter named fade color and multiply it with fade texture parameter just like in the box indicator. And also lerp it with a constant 0 while the alpha will be center with length divided by 0.5, clamped with saturate and increased in strength with power node that will have new scalar parameter for fade intensity, which I will also multiply by 2 because for me it seems to be weak in this particular material setup. Now let's multiply it by cone angle circle with calculated full circle and also multiply it by inverted outline to remove it from everything, which will give us exactly the space where we want the fade to be. This will be called color fade node. This part is quite optional, but I think is really great. Remember these animations with cut off parts from it so it looks really cool? Let's create that for outline and inside. Get angular distance and multiply it by a new scalar parameter called number of cutoffs. Normalize it with fraction and subtract 0.5 from it. Now absolute it to change the negative numbers to positive and add if with this as an a. Create another scalar parameter called gap width and divide it by 2. This will be b. Lastly, create two constants with values 0 and 1 and connect them appropriately. This will be inner triangle pattern. Copy all of this for outline with few differences. Angular distance will be outline 1 and these scalar parameters will be new ones for outline. This will be outline triangle pattern. Now go back to the outline calculation and before we make the cone outline, let's multiply it with outline triangle pattern also. We finally can add all of this together to create this material. First, get outer and inner radius, multiply them. Now multiply it with cone angle circle to mask it properly. Also mask it with another multiply with triangle pattern. Then layer on top of it with multiply inner texture, which is texture 2D made parameter. And fill color, which is constant 4 made parameter. Then add color fade. For the outline, get outline and outline triangle pattern. Multiply them together and add if with b360 and a being the scalar parameter we already created called degrees. Here we will choose if we should use circle outline or cone outline. If a equals b, use circular one, and if not, get cone outline with cone side outline, add them together and plug them in. This will be last named reroute node called selected outline. As always, create texture 2D parameter for outline texture, create constant 4 parameter for outline color, and multiply them with the outline. Now just add the outline with this, and plug them into the base color and emissive color. For the opacity, again, We add the selected outline to exclude it from being translucent. With this, the first part, which is also the hardest part of making indicators, is behind us. Hopefully you made it to work on your first try and that you also learned something new about materials. Thanks for watching, and if you like this video, consider liking, sharing or even subscribing. Every bit helps my sanity and will to make these tutorials for you. Anyways, that's all I guess. Bye!